Hey, let's do some math.
Let's consider this exponential function problem that's a word problem. Let's say in 1999 that something is worth $66,000. And since this is the beginning value, we'll say that t, or the time in years, is year zero. And then in 2009, it increases in value to $220,000. And that would be year 10 because that's 10 years from the start. So the question is if this increases exponentially, what would be the value in 2016? So we're going to use this equation for exponential growth functions. And so this value is the beginning value. This is the value later on. This is a rate of growth. And then this is the time in years. So for a problem like this, what we would do to find this R value for these figures up here, we would say that it started at 66,000 and the price increased to 220,000, and that was in 10 years. So we're just substituting this information up here into this to get that. And so we have to solve for R. So in order to solve for R, we're going to divide by this number first. So divide both sides by 66,000. Which leads to this. So this divided is 3.3 repeating. And of course, these cancel, so you have 1 plus r to the 10th power. Now, from there, we're going to take the log of both sides. And the reason we're going to do that is we're trying to solve for this r value. So if we take the log of both sides, that will enable us to bring this exponent down in front in this next step. So taking the log of both sides, log base 10 of both sides, it looks like that. And then that enables us to bring the 10 down in front by one of the properties of logarithms. And then we'll divide both sides by 10 so we can get rid of that. Of course, this calculation on your calculator is 0.052. And of course, the 10s cancel there, so you have this. Now, this next step is crucial. Remember that a log that doesn't have a base written here is basically base 10. That's a common logarithm. So if I take this log problem and write it in exponential form, it looks like this. Because 10 is the base to that exponent equals that part. So base is 10, so that power equals that. That's how you change something from logarithmic form to exponential form. So it looks like this. So to solve for r, you're just going to subtract 1 from both sides. Of course, you do 10 to the 0.052 power minus 1, and you find out that r is 0.127. So that's the rate. So we found out that the rate is 0.127. So now from that, what we're going to do next is answer the question. So what about the year 2016? Well, we're going to start, the initial value was 66,000, and now we know what the rate is, so we can put that in. The reason I'm saying that it's year 17 is, remember, the start was 1999. So from 1999 to 2016 is 17 years. So if you count, if year 0 is 1999, year 2016 will be 17 years, and you can kind of count up to that 16 years in the 2000 plus that 1 year from 99 to 2000, so 17 years. So you do this on your calculator. So 66,000 times 1 plus 0.127 in parentheses raised to the 17th power is 503,791.12. So over $500,000. So very expensive. So that's how you do a word problem that involves exponential growth. So that's an exponential growth function as a word problem. See ya.